All right, so let's dig into some examples of showing something is a subspace. And I've written some of the first one out here. So here I'm telling you that the main vector space is all of R2. And I want you to determine if H is a subspace, if H has these following criteria. So they're going to be weird. It's going to be different because it's not just going to be all of R2. So this says if I have two vectors in my subspace, then the rules for the subspace are when you add them together, you take 2 times each of the x coordinates and you add 3 times each of the y coordinates. And then how you multiply by a constant is you end up taking the opposite sign. Okay, so first off, so I have to establish the 3 criteria are satisfied if it is a subspace. So there is a 0 vector because I can let u1 and u2 be 0. So there is my 0 vector that is one of the criteria for establishing it's a subspace. So if I take 2 vectors that are in the subspace, then if I add them together, they stay in the subspace. They just happen to have this weird 2 and 3 combination going on. And if I take a vector in my subspace and I take a constant times it, it gives me the opposite sign, but that's still in the vector space. So all 3 things are satisfied. So this subspace H is a vector space. So if we want to show true, we have to show all 3. If one of the criteria fails, you can stop because you're done and you can just say it's not a subspace. All right, so here I've got this next couple done out for you so you can see it. So if I'm looking at all of the 2 by 2 matrices that are of this form, so not every single matrix of size 2 by 2, but matrices that look like this with regular addition and scalar multiplication that happens with matrices. All right, so let's first look at, is there a 0 vector? Well, I can let A and B equal 0, but I'm still going to have the 1s here because that's what all the matrices in this subspace look like. So there is no 0 matrix, right? I cannot get to 0, 0, 0, 0 because things in this matrix, in this subspace, always will have 1s there. So that is not ever going to give me 0, 0, 0, 0. So there's no 0 vector. All right, so if I take 2 matrices that are in this set and then I add them together, so I get A plus C in that position, I get a 2 here, I get a 2 here, and I get a B plus a D. So these here, B and D, B plus A plus C and B plus D, they're okay. They would be just real numbers that would still stay in the set. So this would be just a constant here and a constant here. But this 2 here and this 2 here does not fit the form of the matrices. So it is not closed under addition. And then here, if I take and multiply by a constant C, I would get C's in each of the entries, right? And this is not in the vector space as well because I need to have a 1 here and a 1 here. Okay, so I didn't need, if I was doing this to show this was not a vector space, I would only need to do one of these. I just went ahead and did all of them so that you could see what it looks like. So any one of these gives you the conclusion it is not a subspace. It is not a subspace. Whoops, not a subspace. All right, so let's look at this next example. I've got polynomials that look like this. A t squared, where a is a real number and t is never fixed. This is a big deal. You never fix t. T is just the variable you're allowed to put in any independent, right? There is a 0 vector because I can let a equal 0. So if I let a equal 0, that gives me the 0 vector. So I have a 0 vector. If I have 2 vectors in the set, at squared plus bt squared, and if I add them together, then I can pull their constants out in front and I have a constant times t squared that fits the form of things in this subspace. If I have at squared and I multiply it by a constant, it keeps as a constant times c squared times t squared, so that stays in the space. So this does satisfy all the criteria and it is a subspace. So it is a subspace. I'm sorry, I'm using the word subspace and vector space interchangeable. All right, so let's look at this next example where we get to do it on our own. All right, so I've got this polynomial, things that look like this, where a is a real number, and t, remember, you're never fixing t. So let's go through, and I'm just going to go through in order. So let's see if there is a zero vector. So if I zero vector. So it's always good to communicate to your reader what you're doing. If I let a equal 0, I get p of t is equal to t squared. That is not the zero vector. So there is no zero vector. Remember, you may not let change t. It's only the constants that you can let. So if I was doing this, I could be done at this point. So I'm now just going to show you another option of what you could do to show that it is not a subspace. So if I take two polynomials, so if I have p of t, and you would say a plus t squared, and it'd be your job to make up a q of t, and you'd have to use a different letter, so b plus t squared. So does it work that if I add these two together that I stay in this space? So b plus t squared, so I would have a plus b plus 2t squared. This polynomial does not fit this form because this form says there has to be a 1 in front of the t squared. So this is not in the space. So it is, I should say, actually, it is not closed under addition. Not closed under addition. And again, I could be done if I just did this alone. Or, I'm just going to show it to you so you can see. Let's look at the third criteria for subspaces. So I have to start with a vector that's in the space. And if I take a constant times that vector, that gives me ca plus ct squared. This is not closed under scalar multiplication. Whoops, not closed under scalar multiplication because I have a number in front of the t squared here and I need a 1, right? So you don't have to write that, but use not closed under scalar multiplication. So any one of these, right? You could have done this, or you could have done this, or you could have done this. Any one of these shows it is not a subspace.